She has started recording. Arvind, I think we can get started with the session.
Okay, so I'll just try to share my screen. I it, it Aisha might have to make me host for that. I'll just try sharing my screen. Oof.
Done, sir.
Yeah,
Okay, thank you so much. I'll just try sharing again. Okay, are you able to see my screen?
it's coming. Yep, I can see. Before we start, teams, if you have any questions regarding the session, you can drop your question in the chat, and we can take the question in between the session as well as maybe after once the session is done. So, Arvind, over to you.
Thank you so much, Praveen, and thank you so much, Aisha. So, hello everyone. My name is Arvind Kumar Singh. I'm working as a technical account manager in Mathworks. Along with me, I have my colleague also with me. His name is Vinayak, and he's part of application engineering team. And he supports various engineers who wants to do simulation and modeling in the field of multi-domain systems. Now, as you know, our today topic is also the same, which is called modeling and simulation of multi-domain systems using MATLAB and Simulink. And we will attempt today to understand that how we can utilize this tools and then this simulation methodology in the given problem statement by in the TIFAN agriculture that we see. No, before starting, I would like to bring that basically simulation is everywhere in every industry, may it be aerospace, may it be automotive, consumer electronics, or power electronics. Simulation is everywhere, and those are all multi-domain system. So multi-domain system, it basically means is that it involves multidisciplinary and many engineering, say, discipline to come together to form a particular functionality, and therefore there are various engineers who need to work with each other for the development of these kind of system. One of the motivation is also to help you relate the theory with the system behavior. You would be able to understand, so in my engineering, what I have learned and how I can utilize simulation in order to how may I utilize simulation in order to understand what I've learned in my engineering and to expand my understanding for other domain. Why? Because I might be expert in only one domain, but with simulation, you would be able to understand how the different other domain work and see the behavior of it. Connection with the real-time hardware is also one of the objective, but we'll try to cover only the modeling and simulation part in today's presentation. I would encourage you to drop your queries on the chat, and we'll take it by the end of this session. So moving ahead, this is the project statement that we understand, that we have a multi-vegetable transplanter, and then basically there is a specification given to you by the committee or by the organizer, that okay, this is the way that you want the space between the wheels, and what should be the space between the different bed and all those things. And there will be one tray also where the saplings would be there. Now, if I were to do a simulation, I would definitely try to develop some kind of mechanical hardware which I would like to, for example, say go to a foundry or create it, or maybe use some kind of CAD models, where I would first develop the look and feel of the component, the hardware component, and then basically I will try to using simulation in any CAD modeling tool. I would like to understand whether the movement of those things are together helpful for me to achieve that functionality or not. Okay. Now, hence, given said that, so basically we need to do something called a pickup sapling, hold, convey sapling, dig a hole, and then drop the sapling and cover the soil. And there are many ways of doing it. Somebody might think about utilizing some kind of an robotic arm, which is an electromechanical device. It can be some kind of a conveyor belt, which is taking the sapling and then digging to it. And then at the end of the day, it boils down to a system, which is a multi-domain system or a multidisciplinary system. But going ahead, today we thought that basically we'll try to bring a very similar example, an example which will help you to understand that if I were to simulate these things, what could be the essential element that I should know and learn on the engineering? What is the engineering that I should utilize for the simulation in order to achieve the understanding or the verification validation of the simulation? What do I mean? But so in essence, what does simulation mean? I'll start with that. For example, if I were to say develop a system, I would conventionally say maybe create a design and go to a foundry, have the mechanical part with me, assemble it, and then test it out. But maybe at the end of the day, when I do some testing, I will find out that, okay, the functionality is not achieved. There was some problem with the mechanical design. Then I have again have to redo it. Now the cost of redoing is so much because now your physical prototype is with you, and again you have invested a large amount of time in developing the prototype as well. It takes maybe a month for you to develop the prototype, and at the end of the 1 month, when you assemble the part and you understand it, okay, this is not working, again you have to redo it. It incorporate cost, time, and effort, and then again it goes into a loop. So simulation help you on a very virtual platform. It can be simulation means there is a software on your laptop which will help you to realize the same functionality, and make and give you the analysis that, okay, if you design this part using some mechanism, may it be a CAD model, may it be sim mechanics, how they are performing, how they are working. And when you get a better understanding and confidence that, okay, it is working on the simulation level, you definitely want to go to the next level of uh, of making it physically, giving it to a foundry, and they will make the part for you. So in that case, in front of you, basically, you can see there is a robotic arm. And if you can closely see in this robotic arm, there are multiple parts which are here, and then the multiple motors are there. You can also see there is some kind of embedded device. I call it embedded device, or a microprocessor or a microcontroller. It can be also an Arduino board, which is helping to control this motor to move this part. Now, similar design you can make for your problem statement, that is a transplanter, multi-vegetable transplanter, and if you want to use a robotic arm, or maybe a belt kind of mechanism. In every case, you would be working with these essential element like the motors and some kind of joints with some degrees of freedom, and some electronics which is controlling them. Okay. Now in today's agenda, we'll cover that. Okay, if I have an idea, if I have a design in mind, how would I be able to do it on the simulation level? And I've also brought to you one good demo for you. Just to show you what demo it is, if you can see, this is a robotic arm. I'll just try to run this simulation so that I would try to give you the gist of it, at what we are gonna understand on the top level, that the workflow looks like if I have to build similar kind of system. So this is an interface. This is a MATLAB interface, where this is Simulink environment, where I've created a robotic arm, and then there is a control which is controlling the robotic arm. And then at the end of the day, this is a simulation where I can really see when my control is actually controlling that robotic arm, what is the functionality that I have achieved. If I run the simulation, if I'm running it, just give me a moment. So you can see there is a roller belt, an object is moving in this direction. Now the control is controlling the robotic arm, and it is guiding to the place where this object is. There are two fingers here which is holding the box, picking it up and placing it another conveyor belt. And then the final objective is to place this cuboid from this location to this location using a robotic arm. So here, basically what we're trying to understand, that whether my functionality, my final objective of this robotic arm to pick and place an object, is happening correctly or not. And in this system, you would realize that I don't actually have a robotic arm with me. But what I have done is that I've typically developed a robotic arm from a CAD model, and then wrote some kind of logic in an environment similar to this. Is called a Simulink environment, with the mechanism of control and arm. And this is something also called as a plan model. So with this, let's dive more into it. I'll just segregate this entire demo which I've shown you, that what were the steps on a top level I went through to develop this kind of model. The very first thing, there is a arm which is picking up, and then it is placing it down. And if I were to analyze it more, so basically it contains two things. One is a controller which is controlling the object, and this is a representation of the robotic arm in a software where this emulates the exact behavior of the hardware. Emulation means what are the joints, what are the motors, what is the shape and design that you have chosen for your mechanical part. that is also very important here because that is what you have designed in order to achieve the functionality. This plant model is the exact replica of the actual hardware that you're gonna develop sometime later. But this plant will behave in behavior would be same as that. Why? Because I want to check here that okay, in the simulation world, my controls is controlling this and it is doing perfectly right. The first thing is that how to do it, how to start. I'll start with the plant model first. In a plant model, the object here is the robotica. And just like if I want to reiterate, there are certain equipments here. For example, motor number one, motor number two, motor number three is here. And then there are two arms, one arm, two arm, and then there is a uh, plunger which is holding the object, and some kind of fixed platform is here. What I will try to do, I'll just try to uh, look this in a very different manner. I would say, okay, these are three different equipment which are connected. These are rods which are connected to each other in such a mechanism. And then I would say, okay, there are certain, say, motors which is also connected to them. And in order to model the entire, say, the plant model, I have to model at least the motors also, and have to model the behavior of this as well. So the question comes, how would I be able to do it? Because I don't have the actual hardware with me, right? So the very first thing, let's try to approach it to understand how we can model the motor first, and then we will go how to model this particular thing. So in modeling, basically dynamic system like motors, there are various approaches. The very first approach is called as a data-driven modeling. In a data-driven modeling, basically what we do, uh, we have a physical motor. We'll give certain input to that motor, and we'll capture what is the output, for example, RPM, and take a log of it. For example, if I give input voltage from 0 to this volt, and I will also record what is how the RPM is rotating, and then basically I will use that input and output data to find a transfer function. A transfer function means some kind of equation which will help me to relate your input data to the output data. And once that is done, I will also do one experiment saying that if I model that equation maybe in some simulation tool like MATLAB and Simulink, and then I will try to compare whether the output of the simulation data, that is the estimated system, and the actual system are meeting or not. This is a very simplistic way of doing it, where we are doing some experiment. Experiment is like taking a real system, just like we do in lab. We give it some kind of input and capture what is the output, and utilizing that same information to find the transfer function or model it. That is way number one. Second is first principle method. Now, as you know that you might be also studying in your control systems books in every physical part. For example, here it's a DC motor. In a DC motor can be represented by a set of physics equation. So you can see here that there are certain constant, there is angular velocity, there is current, there is inductance, and based on that, there are two equation. And that equation can be very well built into a Simulink. And when you simulate this, this is actually behaving like this hardware. So now you have moved from data driven to the first principle. A first principle means utilizing the physics equation, first order physics equation, for creating an object in the simulation world. And we need to do something more into it. I will tell you just a bit later. Why? Because we want to make it as close as possible to a real hardware. There is one more step needed. Okay, so now two approach we have discussed. One is data driven method, and second is using the first principle model method. And now the third very important part, I would like to introduce you to something called as Simscape modeling language in MATLAB, where you actually have something called as resistor, operational amplifier, inductors, and mutual inductors. And you know basically, okay, how does my this DC motor looks if I were to look it in the perspective of RLC, that is your resistance, inductance, and resistance. The same way you can model using these discrete active component which is there in this library. And when you realize this, you actually have the model of this DC motor again. So here, basically, you are utilizing multiple tools in order to develop the physical or the plant model of the battery. So summarizing, there are two approaches, data-driven and first principle method. Both have advantages and disadvantages. One is fast and accurate, other is that utilizes the physical parameters. The disadvantages requires plant data acquisition, and third time is time consuming. Now, first principle method is very good when we are working with very simplistic, for example, system. So for example, if I have a potential, if I have a potential divider, it will be very easy for me to write an equation. But if I start cascading potential divider after and after again, the way we want to derive the input and output equation becomes so much cumbersome that this first principle modeling is very effort intensive. And again, you need to be very domain expertise. For example, I need to be a very good electrical engineer or electronics engineer to write the Kirchhoff law and equation for a multi-cascaded, a bigger circuit. So now, having known this advantage and disadvantage, you can also utilize the simscape way where actually the physical component is there. For example, your voltage, inductor, and resistance. And in this case, you don't have to worry about the physics equation, and you can directly model your DC motor using these discrete, say, component like inductance, op-amp, and the resistors. Hence said that, now what I will do is that utilizing any of these two methods, I will create some kind of model equation, which I have already developed, but there is one step left. The very one step left is that how would I ensure that my motor is actually behaving the same as my physical object is, and I would do something called as one more step, which is called as a parameter estimation. So my question is, why would it behave if I have written the same physics equation, or if I've written this different if I use the data-driven model? The answer is that every object has something called as a constant, like resistance, induction, inertia, friction, and everybody comes with a tolerance. For example, resistance is plus minus 2%, or maybe inductance is plus minus something percent. Even with this tolerances, it might be the case that your simulation waveform, which is in, say, yellow, is different as the actual, which is coming. The pink one is the actual, which is coming on the hardware. So the one more step we need is something called as a parameter estimation, where we actually start tweaking this RLZKB in such a way that we change it. If you understand, earlier it was this. If I change it to an experiment, it changes to something else. And with this new value of this constant, your simulation data is now actually meeting with the physical data. Now, what we have achieved at this point of time, we have taken 3 steps. First step is we basically identified what are the object that we want to do. We're using first principle method or second principle method. We developed some kind of a model which is behaving as same as the physical asset. Third thing is that I compared the actual data out of the hardware with my simulation output. If it is not same, I did one step called as parameter estimation, and then I tweak this value. And now the final motor model that I have is the actual plan model of my motor. Okay. Now again, I'll just skip this. These are various methods by which you can basically develop the plan model, and I'll leave it to you for your reference. But let's come back to the main topic that now we have spoken about. We have understood how we can model this now using physical equation or using Simscape and then doing parameter estimation. Now, what about this thing? Now, these things are attached to these different joints, and then these are rotating, and it is rotating in such a way that it is controlling the movement of this robotic arm. So now let's bring this to the topic. Now let's understand how we can start modeling this. The very first step, I'll take pen and paper. I'll just draw all the forces which is acting on this road. I'll take the center of gravity, center of the mass, and then I'll say mg is the component below, and then try to find all the other things. And I can basically write the kinematic equation and the dynamic equation, and then basically again add the another rod and do the same thing, and then again I'll do the same thing. I'll write the kinematic equation, and as the rods, as the different pieces are coming together, this is also going more. And when finally you have that equation with you, for example, for a case of single rod, if this is the equation, you can use MATLAB to model it. And then there is one thing called a solver, which help you to solve this in a very faster manner in simulation. And then basically you can see the different kind of waveforms as well. You can also utilize something called as a Simulink, just like the motor example that we saw that, okay, in motor, we use the physics equation. Similarly here, the derived equation can be modeled in Simulink. And then finally, you have that model. But this seems to be very cumbersome again. Why? Because as the parts are joining, because my part will be more complex than this. It's a very simple robotic arm. I might have maybe 3, 4 more additional component with me, which are connected to each other with motor, or maybe it is moving in such a manner. But is there any simplistic way of doing it? Yes, there is a simplistic way of doing it. Basically, again, what we'll do, we'll change the approach. So what we will do is that we will again see this model in the perspective of different kind of object which are working together with each other. For example, body 2, body 1, rotational joint, ground, and then basically use something called as Simscape multi-body to model this. I'll just come to more detail on this. What happens when Simscape mechanics does this. So basically, I'll just show you in the demo that what is happening in that same graphic that I've shown you. I'll go into the code of it on the top level and explain you. And there is one more way of doing it, and that way is that suppose I know some of the 3D modeling, uh, say software are very popular. For example, SolidWorks. Here you can see that the same robotic arm is being developed here. So you might be also working on various, say, CAD softwares, which has helped you to create this part. You can export this part in an XML format and import it in the sim mechanics, and directly you can get the same thing here. So you can see this logic which is written here in the sim mechanics model. This is exactly replicating that what is the model that you have created in SolidWorks. It saves your time, and I know that you would always start by using the CAD words for CAD softwares for developing your mechanical parts. So the one very good thing is here that you can directly export from here and import here, and then again go to that environment where I showed you earlier, where the simulation was running, and then you can start working on it. Okay. So now at, at this point of time, what we have done, we have seen two methods where we have actually modeled our actuator, actually modeled our plant, and then there are other components which can be used for the sensors thing. Sensor is what is sensing the where this position is or the motor position is, and then the final piece is the control. So the control is basically reading what is the output, comparing it with the desired command, and then controlling this to achieve a particular functionality. So let me explain the meaning of this controller using my example that I have. Are you able to see my Simulink model now? So Praveen, you're able to see this, right?
I'm able to see it, Arvind.
Sure, thank you so much. So now here you can see this is the control and this is the arm. And if I may to again describe you what we have. So we have this conveyor belt. Okay, this is one object. We have this cube as the object, another conveyor belt, and then we have multiple part. Like this is uh, the the two for picking. You need hit it here, and then there are two different parts. Like this is the joint one, joint two, and then these are different kind of things. If I really go inside that model, what you would see, the different things are here already. Your gripper is there, your wrist is there, your forearm is there, your bicep is there. This is created when you import this from your SolidWorks CAD model. And this is the place where it has created the revolute forearms and the other things which is used to connect those things, your arms, and then achieving the functionality. This is automatically created. Now you also have the capability to go inside, and then for example, you want to change something, you want to change the direction or something, and the limits and the actuation. You can these all options comes here automatically, and you don't have to do much here. Now this is the part where your robotic arm is there, and similarly, I've also imported the CAD model of the environment, that is the belt and the object, and then these are the fingers of where which is mounted on the gripper, and then at the end of the day, I'm able to create the entire robotic arm plan model here. Now, if I go to the controls, this is simple control where you can see the sensor input from the belt in and belt out is there, and then the gripper is there. And then basically I have created some kind of logic here. Just for your knowledge, this is called as a state flow logic. This is one of the programming environment in MATLAB and Simulink where you can do decision kind of programming using state flow. And here you can see that there are different, for example, gripper logic is here, your robotic logic is here, your built-in logic is here, and your belt out logic is here. And these four are working in an order to to simulate how your belt, your conveyor belt is moving, and hence your robot and gripper are moving. Nothing to worry at this point of time. This is a very new to you. At the end of this session, I will be sharing you certain links where you can, there are certain on-ramp course available. Those on-ramp course will help you to get started by how you can, by understanding what is Simulink, what is state flow, and then also understanding what is sim mechanics. And with this, you would be able, with that knowledge, you should be able to use this software in such a way to start developing your project. Okay. So here again, if you see that this is the control logic that is actually um, controlling your robotic arm, and then this is the assembly of the robotic arm that is created, imported directly from the CAD model, and this is working in a closed loop. Why? Because this is controlling it, and the feedback is given back to the system, and it is controlling in such a way that it achieves the functionality of picking and dropping the object. Okay. Any questions so far? Okay, so please drop your question on the chat. And this seems to be very overwhelming, but the intention of this session is to show you the dimension that what are the various things that you can do. But we can also connect with each other. If you have a project similar to like this and you want to simulate it on MATLAB and Simulink, we will help you to do it. Okay. The second thing, we can place, just to give you a demo, you can see that basically this is a robotic arm again, and there is a camera fitted here. The camera is looking into the object, and you can see this, there are various shapes, like the various shapes of your pipes are here. And with the camera, it is able to identify the object. That is something called as perception, sensing and perception. It is able to understand the shape and size, and able to correctly put it into the different bins that it has. Now, if I can relate, for example, if it's a multi-vegetable transplanter, and if you want to understand that, okay, what are the vegetable sapling that you have in this bin or in that bin, then image processing can be also one of an example where you can utilize machine learning, deep learning, and artificial intelligence to understand that what kind of plant it is based on the camera input, and then hence you can basically achieve this functionality. So, summarizing it, basically what we understood that we saw different branches of engineering: mechatronics, robotics, and data analytics. And these are the various things that we talked about. For example, image, perception, dynamic. And this is something which is very related to the branch of engineering that we are studying in colleges. So my point here is that uh, we are thinking beyond what you beyond this competition. And if you want to understand what the industry trend is, what the industry is going into, and these are the various disciplines where they want to utilize engineering to achieve a certain task. For example, predictive maintenance, it can be your decision logic, planning and optimization. And this example that I've shown you will help you to understand each of them in detail. With this, I would like to share you these resources. These are the different, this is the example that I used in MATLAB to demonstrate you the entire workflow, that how you can import the CAD model and then simulate it, how you can develop the controls. I've showed you Simulink, Stateflow, Simscape. And then these are the free hand-on tutorial on Simscape and circuit simulation and on physical modeling. And similarly, I will provide you some of the freely available on-ramp on MATLAB, Simulink, and Stateflow. So with this, I have come to the end of this, and let me know if there are any questions. So does the robot arm is cost if efficient is one of the question. So here basically with this analysis, what we're trying to do is that we are trying to identify a design which is cost efficient. It might happen that you would say, okay, in order to achieve my objective, I might need three arms, or maybe two arms, not three, in that sense. But this is a very standard robot, which we have for the demo. But your design would be different, and you want to develop a different system for the particular TIFAN project statement that we have. So this is my last slide. If you have any questions, just kindly let me know. Okay. Aisha and Praveen, are you here?
Yes.
So Praveen, i- this is what I wanted to share today,
Mm-hmm.
and I think we are at 45 minutes by the time of the meeting.
Mm-hmm.
Do you have anything else to talk about, or good?
Not me, but I think I have a couple questions on the chat that I would like to read and maybe we can answer.
Hmm.
So I think Google S has sent a question. So does the robot arm is cost efficient? So if you can add some cost detail, if student have to develop something for this kind of implement, whether it's going to be cost efficient, how much it add cost to the implement, anything on this, and also like on in terms of time requirement to do all these simulations and what kind of level of expertise that they need for this tool. If you can add
So
those details.
yeah, so basically, I'll say the first step to understand this is doing the on-ramp. That will help you to get familiarized with these things. For example, this Simulink, Stateflow, Simscape. That is the first step. Okay. If you have the CAD model with you, will help you to import that and create a basic model for your analysis. And then the rest part is developing the logic for your embedded device. So I'll say that simulation helps you to do your analysis of your idea quickly as possible. It is also, you can also use rapid prototyping. So I would say that as compared to the conventional method where you wait for the actual hardware to come, this is the time consumption is very less in the simulation world. Okay, that is one thing. Second thing, I can provide you the cost of this robotic arm if you want to utilize this for your project. That is one thing. So I have one more question from Akash. Is robotic arm is perfectly suited for this problem statement? Now, this is one of the example, Akash. You need to understand that how you want to say do it. I just brought this example to show you that if you want to say simulate the CAD model that you have, what can be the mechanism?
Um, Something that also like to add to what Arvind is saying here um, is that what you have seen is evaluation tool, you know, and when you saw the simulation, when you run the actual simulation, you'll be able to understand where the different forces are acting, what kind of different loads you had at different, joints, and then you can decide what kind of motor, what specification you require to use it, and then based on this, you are going to choose, okay, from this some shop you're going to get motor or gripper and so on. So that is basically one of the main uses of making a simulation, and that is going to help in for you to understand which will be the cost efficient or most accurate or what you want to do with respect to your implementation.
Great. And one thing more, for example, you would have created two, three designs, but how would you know that which design is the efficient? Maybe I'm using robotic arm for one, or maybe I'm using a conveyor belt for another, or maybe I'm using some entirely different assembly for that. So this simulation will help you to simulate this in this world and do the analysis, the cost analysis and the performance analysis, saying that, okay, which design is the best? And then based on your analysis, you can choose one design and go for the final, say, creation of the hardware. In that sense, it will help you to be more cost effective, and you're sure that you have the very optimized design out of the different design that you have created.
Thank you, Arvind, and thank you, Vinayak. Team, if you have any other questions, you can drop in chat, as well as if you want to unmute and have a direct interaction with Arvind and Vinayak, feel free to unmute yourself. So, Arvind, maybe like from my side, although you have shared what are the different capabilities that tool possess and how we can utilize this or leverage this tool for the implement design. The students who have not joined, is there any kind of online document that they can refer or online video that they can refer
Yeah.
just for a refresher and just go through it, hands-on experience if they want to take it?
So what I will do, Praveen, I'll share those links.
Mhm.
Okay. And then this entire model I will share with you. So this I've opened this in MATLAB 2022B, and
Okay,
soon I'm in the final stages of rolling out the instruction how to download MATLAB trial for the student teams.
okay, great.
So you can directly open this from File Central in Mathworks. You can get this directly, and you can start looking into it. It's a ready-made thing. It's available to all,
Mhm.
and then all the say help file which is required is here. You can just click on one, and it will tell you that okay how it has been created,
Okay, great.
and basically there are various. There is a File Central help also available. I will share that with you where it tells that what are the block. It gives you very detailed about it.
Mhm.
So all the information, what training you need, what module you need is everything is there. I'll share that with you and Aisha for dissemination to all the um, team members.
I think that would be a great help. Teams, we still have 13 more minutes. If you want to utilize this time to have an interaction and maybe share your problem statement, where you're stuck, how you're going to use the math work in your simulation, recommend leverage this time, have this direct interaction with our experts here. Okay, hearing none, looks like everyone got to know the gist of the MathWorks now. They're just ready to implement it directly. That's good. Uh, if you have any questions on rulebook side as well, I think me and Shushant from TIFAN2024 can take up those as well. Okay, I'm hearing none on the rulebook side as well. I think technical team has done a really good job now. Okay, great. There's nothing from the student side. Thanks, Arvind. Thanks, Vinayak, for this session. Teams will consolidate this session recording and it will be available at our students corner in a day or two. We'll see you next weekend. Oh, sorry, next week, Friday. Thank you
Sure.
everyone for the joining. Thank you, Arvind.
Thank you,
Thank you,
Praveen.
Vinayak.
Thank you,
Again.
Aisha. Thank you, everyone.
Thank you.